All right. Hi, everybody, and welcome back to the DSS Break. It's great to have all of you with us today. We're here live every week to discuss the world of data science, AI, and machine learning. And we chat about unique experiences and best practices with leading data professionals in a 15-minute break. I'm Anna, the founder at Data Science Salon, and today I'm streaming directly from our headquarters, which is located in the heart of Miami, just a few blocks from the Design District. And today I'm really excited to welcome Zach, the Executive Director of AI and Data Science at JP Morgan, for an insightful exploration about topological data analysis, or TDA. It's a mouthful. Financial discovery, and Zach will dive into how TDA can revolutionize financial analysis by revealing intricate patterns hidden within complex data sets. And I'm really excited about this topic, Zach, because I don't know much about this. And we've had so many people register for this topic that I think it's actually, a lot of people are really interested in it. So thank you so much for being here and joining us.
Oh, thank you so much, Anna. I want to say hi to you and all the audiences of this channel. And thank you for having me for this break.
Of course. No.
I think I also need to start with a disclaimer. Usually, I guess, here I'm required to mention that the views expressed here are my own and do not reflect the views of my employer, JP Morgan, as a housekeeping here, I guess.
Thank you. Well, I appreciate that. And let's go ahead and dive right in. And I would love to first learn about your journey and what got you interested in data science and AI in the first place, Zach.
Sure. I think there are so many ways that I can answer this question, but probably I can say that I started learning coding at a very young age. I wasn't much of a game player myself, but I was always fascinated by the idea of developing game code. I think my fascination with AI began with my interest in robotics. I pursued a bachelor degree in robotics and AI, and also during my master degree, I focused on reinforcement learning, multi-agent systems at the time. But for my PhD, I thought, I want to really challenge myself to a new field. I thought probably there's not going to be harder problems solving the physics that govern the universe. That's why I decided to get my PhD in astrophysics. Probably you guys know that, we gather gargantuan size, data in astrophysics so basically, analyzing such massive data sets needs a lot of analysis. The machine learning, think about it as like taking the images of the sky. You need to have some sort of machine learning to identify the objects, basically do a lot of analysis on that. So there are a lot of data science tools that along the way we need to actually practice and implement. And of course, when we deal with those gigantic data sets, is actually the big data in the truest form. So we also needed actually to learn or do a lot of implement a lot of tools that actually are being developed in the industry. So I think that during my PhD, I did a lot of data analysis and bringing my background in AI and machine learning into my new field of astrophysics. And after my PhD, I actually got Doris Sloan Prize Fellowship in Innovation in Data Science and also Dirac Prize in Physics, which basically gave me opportunity to bring more of AI, machine learning, and actually do more research in the related fields. So I created machine learning pipelines for online discovery of new objects in the universe, and we did a lot of that. And along the way, I also was working as a part-time consultant for various startups, for bigger companies, basically. So basically, eventually I decided that I want to explore the industry full time, which led me to join Microsoft a few years ago. I transitioned to the financial industry joining JP Morgan, where I am now the Director of AI and Data Science for Asset and Wealth Management.
Well, thank you so much for sharing your story. That's a great one. And congrats on all those grants and awards that you won. That's amazing.
Oh, thank you.
And now let's go ahead and dive into TDA. And maybe you could explain what it really means and its relevance in today's data-driven finance sector.
Sure. So let me first explain topology or topological data analysis. I want to make sure that people don't think about it as like a very strange thing. So we all familiar with the geometry. So there are two disciplines in mathematics that study the shape. One is geometry, the other one is topology. So when we think about the geometry, we usually think about what is really important in geometry is the distance between data points. They cannot be changed, basically. But topology is kind of a looser version of geometry. So in topology, think about it like we can, if you have, when you plot the data, basically when you create like a shape, you can stretch the shape, you can bend it, you can bend it, you can twist it, you can play a lot of actually distortion with the shape. And we say that those features in the data that remain invariant under continuous distortion of the space are the ones that we call them the true features of data, basically, or we call them the topological features. So we all kind of work or look at, topology in various ways. Let's say, let's just start with a very simple, examples. Let's say when we plot the data in a 2D space, like X versus Y, if the data kind of been scattered along the kind of a straight line, the shape of data kind of tells us something about the meaning of data, right? So basically one of the models that actually we use, they say that the data has shape and shape has meaning. If we look at the data, shape of the data, it feels like a cyclic, basically kind of tells us about that there's like a time series with a specific periodicity, or there's a periodic time series data. It could be like financial time series data or any other data. Or if the data being like a scattered, along like some sort of clustered or bifurcated, so this shape, we already kind of actually look at those shape and say, okay, that shape tells us some meaning beneath the data. So with topology, we are aiming to go a little further, we want to go beyond the surface, as exactly the title of this conversation. And we say that, all right, let me kind of make it more relevant to finance. So when you look at the data sets, and actually financial data set of financial markets, data are coming from various sources.
Right.
And each source can have its own, metric, how data being measured, basically. And also data has a lot of noise. So topology can be relevant here. Topology basically looks at the data and says that, all right, we can find some sort of features in the data that is really not dependent. So kind of removing those noise from the data and removing those scales that kind of been inherited in the DNA of those data because they gathered from different data sources, basically. So it's very relevant because we really want to understand what really data kind of, underneath tells us. We really want to remove all those noises basically from the data. And this is a very kind of unique way or a way of actually looking at the data. Maybe I can finish by saying that usually when we look at the traditional data analysis, we are basically mainly looking at the statistical properties of the data, and they are very, very important. So the topology, by looking at the shape or structure of the data, we are kind of a new way. So it's not like we are replacing this traditional data analysis. We are basically just enhancing those traditional analysis with more of the features that we can actually add to those ones. So again, hopefully it's not something very strange. We all have been familiar at some level with this topology.
Yeah, no, that makes a ton of sense. And my next question for you was, how are AI advancements like Gen AI enhancing the application of TDA? in finance, if at all?
Of course, that's a great question. So when I think about Gen AI in the context of topology or topological data analysis, I think about it as a tool. So Gen AI can give me, I can think about Gen AI in the context of synthetic data, synthetic data creation, basically. There are many places, whether in finance or other fields, for some reason, we either don't have access to all the data, or data being, there are a lot of things that actually makes that actually we wanted to kind of create synthetic data. Let's say we want to simulate the market in different regimes that actually we haven't seen them, basically. So those scenarios that actually can exist in the market, we haven't observed them, so we don't have data. And synthetic data creation using Gen AI really can help us. And one good thing, again, is that however that synthetic data kind of look at the pattern of the data and just, create kind of samples from the same distribution that actually we kind of want to distribute. Data looks like follow distribution. But as I said, we are trying, when you look at through the lens of TDA, we kind of remove many of those, artifacts that actually be added to the data. So basically, that's kind of one way of thinking about how Gen AI can help topological analysis. But also in downstream, I also find that sometimes it's really hard to interpret the results, to stakeholders, to people who are not familiar with the concept. And I think having something like, large language models can actually sometimes help us with, how we can interpret more easily, find a language that actually can kind of tells our stakeholders in a more simpler, description that how we can actually present the result to them. So that's kind of, upstream and basically like downstream, basically actually that how we can augment our TDA with the capability that something like Gen AI can provide us.
Cool. No, very cool. Thank you so much for sharing that. And beyond TDA, what other emerging AI tech do you see playing a critical role in the future of finance and the financial service sector?
Of course, that's again a very, very great question. So I can definitely say something that makes me excited, and one of those things, as a physicist who work also in quantum computing, definitely I say that quantum computing is one of those emerging technologies that can help a lot the financial, whether it's financial or other fields, but that's going to have impact on financial data analysis. So whether it's like quantum computing or can be like quantum machine learning, or how we can actually recreate some of the machine learning tools that we have through quantum computing algorithms. So that's one of the things that makes me excited about emerging technologies. There are other things that I think have been, they already exist, but I don't think that the community kind of needs still time to grasp and appreciate more. One of them is about the causality. Especially in finance, we are going to definitely talk about how we can explain the data. And of course, one of the ways that actually we can actually inherit, our methodologies with explainability if we design those tools through like causality. And I'm basically focusing on like do calculus type of causality that actually we can use. So I myself work on that field also, but also I feel that definitely is going to get it's going to get more attention, hopefully, from the community. There are other ways, basically, as we talked about Gen AI, and there are many places that we can still, we really need, our field is really, there are so many opportunities for us actually to bring more of Gen AI. So LLM is just one of them, but let's say how we can actually use Gen AI for creating like, one of the things that actually, for example, I'm thinking about is, let's say that so we always need the actual, one of the tools that usually we use in Gen AI, we call it like RAG, or retrieval augmented generation, basically that we kind of need to impose our documents to the LLMs. But there are other, so one way that actually can make it more conceptually make more sense is using something like knowledge graphs. So graphs also have been used in this field for some time. But I think, merging kind of knowledge graph and RAG and LLMs is really a suitable place actually for financial data and how we can actually kind of merge all these. So there are a lot of exciting things that actually can be done, and makes me really excited actually about how the future gonna look like.
Yeah, no, it sounds like it. And that brings me to my next question about, what about ethical considerations and regulatory requirements when implementing these technologies? I'm sure it's not easy, right?
No, for sure. So, of course, when we usually talk about finance, there are two main things that always comes into our mind, right? Basically, one of it is like compliance regulations. We are talking about a very highly regulated industry, and the other one is basically about the ethical consideration. So when I think about, I think every firm, every industry needs its own kind of ethics group, which actually we have at JP Morgan, ethics group, AI ethics group that kind of provide guidelines or help us to better understand how we can actually incorporate or think about that ethics, or type in the DNA of every algorithm or any methodology that actually we create there. So I can say that, so when we think about in terms of ethics, things that comes into my mind is like how we can actually think about the fairness, how we can actually think about removing the biases from the data. I'm currently working on a project that there are a lot of bias in the data, that basically how we can actually remove all the biases, all those, and kind of create some sort of fairness in our data. When we get to the, so understanding that what really ethics or ethical consideration, definitely can be helpful, and how we can actually bring those concepts into our analysis or any tools that actually we create. And when we get to the compliance, of course, every financial industry or company has its own regulatory kind of sectors that we actually kind of need to follow all the guidelines. But when I think about it, and in terms of, as a data scientist, when we are in this field, I kind of like to think about how we can actually, I'd rather actually kind of create some sort of a strategy for my models. So basically, I'd rather to actually think about that there are part of the problem that we are trying to solve that may or may not need the AI or machine learning. So as a data scientist, we need to identify that there are components in the problem that can be used, like just modeling. I'm not focusing on the AI or ML, like general ML, general modeling can help. And that kind of, because we can thought it as if like every problem can be considered as a black box, which we usually, think about it as, AI or ML as a kind of black box in our solutions. But how we can actually look at a component inside the black box that could be like white boxes or gray boxes, basically. And when I'm talking about those modeling, I'm talking about the modeling that they have like some sort of theoretical guarantees that we can call those are like white boxes. So when we talk about like compliance or how we can actually think about like more explainability, we can really explain those models. And there are places that actually AI, and we can, there are places that we need to use AI, machine learning, because those modeling cannot work. And that's basically, so basically by combining the model-based and AI-based and kind of combining all these, two approaches, we can actually create a more explainable that we can then actually converse or, kind of present that we are not only dealing with it all, a black box model. We kind of actually thought about each compartment in our model individually, and we can actually, so there are a lot of things that actually need to consider. That's kind of my approach that I think, it's never good actually to dump all the data to an AI model and, the result. Basically, you need to think about what you're giving to any models and what's the expectation that actually it can have from output.
Yeah, no, 100%. That's a great answer. Thank you. And one last question I have for you, and I asked this from all of our leaders in this space. What advice would you give to data scientists who are just starting out, or folks that are interested in entering the space, specifically in the finance industry?
Of course, that's a great question again. So I think every field, you're talking about finance. Finance is a field that actually has its own challenges and, of course, its own rewards. Thinking that, by solving problems in the finance, we're really helping people, and we can actually see that, what we are creating is going to affect, people's, way of living, basically. So that's kind of, the rewarding feeling that actually you can get, that, what you're really doing is going to affect, hopefully, if you're doing it right, you're actually affecting people's life in the right, So that's kind of, but again, we should also think about all the challenges that really comes with the finance. And as we kind of touched on, what makes finance different from other fields is more the regulatory environment that actually we have to deal, and also the explainability that actually we also need to offer with anything that we do. So basically, those are like two pillars that we always need to think about. But if I want to add a couple of things more, basically, so what really, in terms of advice, so I think knowing more about, so understanding the domain knowledge about the field that actually you want to enter, because there are so many sub-fields inside the finance. Finance is a very old discipline. So basically, every vertical that you enter, it has its own knowledge kind of domain that actually you need to understand. So that's kind of make it very kind of a specific in that terms. But the thing that is kind of common among all these verticals, I can say, is like thinking about risk management. And I think that's the common component along all the, every vertical or every discipline inside the finance. That whatever we are dealing with a project, we always need to have, along the process, we need to think about how we are accounting for the risk in various stages, how we can actually kind of mitigate do a risk or issues that can actually happen. So understanding that, better understanding the fields and kind of learning more about, the specific field that those folks are interested in, also start thinking about, the risk management, because that's not the kind of thing that, let's say if you're a data scientist, other field, maybe you really don't need to think about it that much. But in finance, that's one of the things that's always with us, that how we should think about, the risk management. And if I want to finish it, basically, I can also say that, because in the finance, we're always dealing with the legacy systems and legacy kind of point of view, they're like old point of view. And many times, actually, when I think about it, there are many problems that, one of the things that we always need to ask ourselves and also our stakeholders is that if you're really framing the right questions, because there are many times that actually that we really, because many times we are just solving the same problems with the new tools, that is it really, but sometimes, if we just look about the problem out of the box, if I may say, and think about what we're really trying to solve. When we are dealing with like a legacy, industry, that there are a lot of things, there are a lot of baggages come with, the way that people actually think in this field. So how we can actually help to frame the question in a manner that actually we are addressing the right question rather than just solving targeting the right question, I think, is very important, specifically in the financial industry.
Yeah. Thank you so much, Zach. That's a great answer. And thank you so much for spending time with us today and for sharing your expertise with our audience. It was a pleasure to have you. And if you guys enjoyed this session, Zach is going to be doing a full presentation about TDA and financial discovery in person on June 18th. So I look forward to seeing some of you there and definitely seeing Zach there. And I hope the rest of you have a wonderful rest of the week.
Thank you. Thank you again. I look forward to June 18th for that meeting. Thanks.
Ditto. All right, guys, we'll see you later.